In the previous session, we have discussed the non-preemption priority scheduling. Now we will move to priority scheduling with preemption. I am considering the smallest value has the highest priority. The smallest value has highest priority. These are the 5 processes, the corresponding arrival times, burst times and priorities. Okay, simply draw the chart. First, at arrival time 0, step by step check the milliseconds. At arrival time 0, we have 2 processes enter into the system. What are the 2 processes? P1 and P2. We have 2 processes right now. So if you have more than one process, on that case we have to check the priority. So the priority for process P1 is higher than P2. Now what to do? P1 execute for 1 millisecond. Is any another process entered into the system at first millisecond? No. So execute for 1 more millisecond. 2. Is any another process at 2 milliseconds? No. Now 3. Is any process entered at arrival time 3? No. So what is the maximum burst time it required? It required 4. Now 4 is completed. The total burst time for process P1 is completed, and before this arrival time no another process is entered into the system. No another process is entered into the system. Now how many processes you know? Before 4 you know only P1 and P2. P1 is completed. Now execute P2. P2. What is the procedure? Again we have to compile 1 millisecond. Suppose 5. At arrival time 5, is any another process entered into system? No. 6. At time 6, is any another process entered into the system? Yes. Observe carefully. At time 5, no process is entered into the system. I am executing 1 more millisecond, that is time 6. At time 6, the process P3 is entered into the system. P2 required burst time is 1, actually 3, 2 units completed. Now what is the priority? What is the priority of the newly coming process and the running process? The newly coming process has the highest priority compared to running process. Then what to do? You have to perform preemption. You got it? The newly coming process has the highest priority. Then simply preempt the process. So stop P2 and allocate the CPU to process P3. Allocate the CPU to process P3. P2 requires 1 more unit of time. So come to P3. Suppose P3 is executed for 1 millisecond. At 7, no process. 8, 9, 10, 11. For example, at 11. Why? Because after 6 we have 11 and P3 requires a total 7 units of time. Actually it requires 6 plus 7 up to 13. At time 11, process P4 enter into the system. The priority for P4 is 3. The running process is P1. Sorry, the running process is 1. So P3 is executed for 1 more millisecond. The newly coming process, that is at time 12, we have process P5. The priority is 2. The running process priority is 1. So it executed and the total 7 units is completed. The total 7 units is completed. Now see the same procedure what we implement in SRTF, shortest job remaining time first. Once we reach the maximum arrival time, the remaining part is completely similar to non-preemption approach. That means these two are completed. Now execute the process according to their priorities. So 2, 2, 3. It is already in execution mode. So prefer execute this one. P2 It executes the remaining 1 unit, that is 4. Next this one P5, it requires 2 units, 16. Next to P4, it requires 420. You got it? Up to the maximum arrival time, it is somewhat difficult. That is second by second you have to execute and check where any other process entered or not. If any other process entered, depending upon the problem, if priority, we are checking the priority. If SJF, we are checking the burst times. And the remaining procedure is same. What is the completion time? Process P1 is completed at 4, P2 is completed at 6, P3 is P2 is completed at 14, P3 13, P4 20, P5 16. Right? Now turnaround time is the completion time minus arrival time. 4 minus 0, 14 minus 0, 13 minus 6, 20 minus 11, 16 minus 12. These are the turnaround times. And waiting time is turnaround time minus burst time. It is called waiting time. 4 minus 4 0, 14 minus 3 11, 7 minus 7 0, 9 minus 4 5, 4 minus 2 2. So what is the answer? 11 16, 16 plus 2 18, 18 by 5. Okay, approximately 3.6. So approximately 3.6. This is the priority scheduling algorithm with preemption. No problem. We will discuss one more example also. Okay.